In this video, we're going to be looking at the importance of electrolytes within the body. In fact, we're going to see that these electrolytes are absolutely essential for neural impulses. Here's a neuron coming down. It's innervating a skeletal muscle cell. In order to send action potentials down this neuron, in order to stimulate a muscle cell to contract, you absolutely have to have electrolytes. Sodium and calcium, potassium. We're going to see electrolytes are extremely important in the heart and EKGs. It's important in the movement of solutes by osmosis into and out of cells. Electrolytes are important in IVs. They're so important that you've got a multi-billion-dollar industry built on putting electrolytes in bottles and having you drink them, such as in Gatorade and Propel. These have electrolytes in them that you need when you're working out really heavy and you're sweating and all. Actually, you get plenty of electrolytes from the food that you eat. You really only need to have these type of drinks. If you're really pushing it and you're really sweating a lot, then yeah, these are good for replacing those electrolytes. But water really is the most important substance that you need to be taking in. Action potentials travel down membranes of muscle cells, neurons, and it's a movement of these two electrolytes. Sodium's going to move in as potassium moves out, which is going to give you your action potentials. What exactly is an electrolyte? An electrolyte is a substance, has an electric charge, either positive or negative, when dissolved in water. And here's one of the important points. It can conduct an electric current, hence the name an electrolyte. An example are ions. That can be an atom or it can be a molecule with a net electric charge due to either a loss or a gain of one or more electrons. Here are some examples of important electrolytes that we have in our body. We have sodium, potassium, chloride, bicarbonate. And notice that we have sodium here, it has a plus on it. That's the charge. It's a positive charge, which means it's missing an electron. Potassium, missing an electron, gives an overall positive charge. There are more protons than electrons orbiting that nucleus. You can have calcium. This has a 2+, meaning it's missing 2 electrons here from its normal orbit. Yeah, magnesium, phosphate. Well, you get these electrolytes through the digestive tract. Or if you have an IV, it can come through the IV. And their loss occurs mainly through the kidneys, with a lesser amount being lost in sweat and feces. As I said, electrolytes conduct electric current. So I have here a light bulb, and there are wires here to complete the circuit. You have your battery here, and you complete the circuit. You can take this little switch, and you can plug it in here, and then that will complete the circuit, and the light will shine. Instead of having this right here, where you bring down the switch, you can have this going through a battery and it's coming through these wires here and through the water. Now, pure water doesn't have electrolytes in it. It just has H2O. And so you can't conduct an electric current through pure water and the light bulb doesn't light. Well, if you put in some sodium chloride, then the sodium is going to dissociate from the chloride, these crystals, and you're going to have positive and negative charges. You're going to have positive sodium charges, you have negative chloride charges, and this conducts an electric current. They are electrolytes. And what do you get? The light bulb turns on because they can conduct an electric current. It's an electrolyte. Non-electrolytes, well, these are substances that do not have an electric charge, either positive or negative, when dissolved in water, and thus they do not conduct electricity. Common organic molecules such as glucose, lipids, creatinine, urea, they don't have an electric charge. If I put sucrose into solution, doesn't have an electric charge, here we have the pure water, light bulb doesn't light up. I add the sucrose to it, again, doesn't have an electric charge, it's not an electrolyte, the light bulb still doesn't light up. Why? Because sucrose is not an electrolyte, does not conduct an electric current. And sucrose, we're going to see, consists of a molecule of glucose hooked to a molecule of fructose. It's table sugar. Let's test our knowledge. Go ahead and pause the video and answer the questions. Here are the answers. Cation versus anion. Well, cations and anions are two types of ions. Ions are the electrolytes. They have an imbalance of an electrical charge, meaning they contain different numbers of protons and electrons. Remember, in the nucleus, you have protons and neutrons, typical nucleus of an atom. Well, the number of protons equals the number of electrons in a neutral atom. But if you have more electrons orbiting than you have protons, you have additional electrons out in this orbit, then you have what's known as an anion. It has an overall negative charge. If you have less electrons orbiting that nucleus than you have protons, then you're going to have an overall positive charge because the protons have a positive charge, and you'll have more positive charges than negative charges. Whereas the anion, protons have a positive charge, and electrons have a negative charge, but you have more negative charges than you have positive protons. That's going to give you an overall negative charge. And we call these ions. We have cations and we have anions. Now, cations, you want to make sure you star this. These are ions that have a positive electrical charge because they have more protons than electrons. Examples: sodium, potassium, calcium, magnesium, and hydrogen are all cations. And I always associate cations with the T here. The T looks like a positive charge. Anions don't have a T. That reminds me that cations have a positive charge. Another thing is I like cats. Cats are good. They're positive. Anions are ions that have a negative electrical charge because they have more electrons than protons. The way to remember this is that if you replace the A with an O, you have onions. And onions are bad or negative. Actually, I like onions. However, on date night, they're bad, especially if your date is not also eating onions. It can cause bad breath. So you want to have both eating onions or both not eating onions. So think of onions as bad, but they really taste delicious, especially sauteed onions. Oh my gosh. Anions are the negative charge. Major anions in the body: chloride, bicarbonate, phosphate. See the negative charge after these ions? Electrolyte concentration directly affects water balance and the movement of water by osmosis between intracellular and extracellular compartments. Intracellular is what's inside the cell, extracellular is outside the cell. And these electrolytes are going to determine this movement of water in and out of the cell by a process called osmosis. We'll be going over the details of osmosis soon. Let's test our knowledge on cations and anions. Pause the video and answer the questions. Here are the answers. When you look at the units used for electrolytes, they're usually given as milliequivalents per liter or milligrams per deciliter. Well, milligrams per deciliter is pretty easy. It's how many milligrams you have in a deciliter of fluid. A deciliter is 100 milliliters, or 1/10 of a liter. Well, what about milliequivalents per liter? It's the number of electrical charges in 1 liter of solution. So to calculate this, you would take the ion concentration in milligrams per liter, divide it by the atomic weight of the ion, milligrams per millimole, times it by the number of electrical charges on one of those ions. And that's going to give you a milliequivalent per liter. So when you see milliequivalents per liter, you need to know that that's a unit, and it's usually used as a unit to measure electrolytes. But you don't have to calculate these. I'm not going to ask you to calculate using this formula on how to get to milliequivalents per liter. Let's pause the video and answer the questions. Here are the answers. When you look at the comparison of electrolytes within body fluids, what we find is that extracellular fluid electrolyte levels differ from those that we find in the intracellular fluids. You want to make sure you star these. Extracellular fluids, sodium is the most abundant cation, and chloride is the most abundant anion. In the intracellular fluid, or what's within the cells, potassium is the most abundant cation, and phosphate is the most abundant anion. And these electrolytes of the extracellular fluids are similar between the interstitial fluid and plasma. Now, plasma is what you have in the blood vessels. Interstitial fluid is around the cells. So when we talk about extracellular fluid, that's basically fluid outside the cell. What does extracellular fluid include? Well, it includes the interstitial fluid that's right around the cell and the plasma that we find, the fluid in the blood. So electrolytes of extracellular fluid are similar between interstitial fluid and plasma, but there's an exception. Plasma contains higher amounts of proteins, particularly albumins. The following are clinical blood serum plasma values for important electrolytes. Note, when you're looking at these values, the ranges are relative to measures used by the source lab that's giving you those numbers, and these can vary slightly. For example, sodium, 135 to 145 milliequivalents per liter, that could be given in one lab, and in another lab, it's using its normal sodium levels, maybe at say 125 to 135 milliequivalents per liter. We're going to use the values were found in Davies' Comprehensive Handbook of Laboratory and Diagnostic Tests, the 7th edition. This is used by numerous colleges, universities for their nursing program, and it's also a really good source for physiology information about electrolyte values. You want to make sure you memorize these values and their units. Phosphorus and phosphate. Well, these can be used often interchangeably. Phosphorus is an element that combines with other substances to form organic and inorganic phosphate compounds. The terms phosphorus and phosphate often used interchangeably when talking about testing, but it's usually the amount of inorganic phosphate, PO4 3-, in the blood that's measured with a serum phosphorus phosphate test. That's just a note. You're not going to have to know that information about phosphorus and phosphate on an exam or quiz, but just to give you a little bit more information as to why you'd see phosphorus versus phosphate on a laboratory test. Well, ways to remember these values. Well, this is a really good flashcard way to remember it, and writing them out. Make sure you can go, okay, sodium, what's the value? What's the range? 135 to 145 milliequivalents per liter. So you want to write that out. There's also a saying here about little Maggie that you can read through, and if it helps you to remember in this way, then great. Common types of electrolyte disorders, you want to make sure that you know the normal serum plasma blood electrolyte level and the name of the disorder if the values are above or below normal. Hyper means too high, higher than normal. Hypo means lower than normal. And emia means pertaining to the blood. For example, if you're looking at the electrolyte sodium, hypernatremia is a higher amount of sodium than normal in the blood. Hyponatremia is a lower amount of sodium in the blood than normal. So you want to go through and make sure you know each of these electrolytes that we're going to learn and what it's called when it's higher than normal and lower than normal. Learning the normal values is important as lab tests are used to help diagnose, monitor an illness, and the patient's response to treatment. But realize that depending on the lab standards used in a particular laboratory, the values may be a little different, especially if they use different units. But the goal is to make sure you understand those that I've given you, the normal ranges, and then to get you to a point where you can analyze a laboratory test and recognize an abnormal result, and most importantly, understand how the normal physiological processes are interrupted and how the body works to return to homeostasis. And we're going to go over a lot of that information when we get to the electrolyte unit. Typical questions about abnormal lab values on our tests, and as well as standardized tests, will have values that are way off from the normal range. So for example, a patient has a total serum calcium level of 14.5 milligrams per deciliter. How would you classify the patient's blood calcium level? First, you have to know what the normal value is. And that's what you're going to memorize from those values that I've given you earlier. Normal is 8.2 to 10.2 milligrams per deciliter. So if they're at 14.5, how would you classify their calcium levels? Hypercalcemia. Go ahead and pause the video and answer the questions. Here are the answers. Go ahead and pause the video and answer the questions on clinical blood serum plasma values of these important electrolytes. Here are the answers. These are common electrolyte disorders. Pause the video and answer the questions. Here are the answers. This concludes the video, and if you have any questions at all, don't hesitate to contact me